Okay, so first of all, in order to do this, I set each inequality for y. I solve the inequality for y. So I'm going to do this one here first, do this one up here. So I'm going to say that negative 4y is greater than or equal to negative 2x plus 12. So I move the 2x over. Divide by negative 4, divide by negative 4. Now remember, I'm dividing by a negative, which means my sign switches. And I'm going to split these up so that I can reduce them. And then this gives me is less than or equal to 2 over 4 is 1/2 minus 3. In fact, I'm going to put a 1/2 there. Alright, so there I have my y-intercept form, or slope-intercept form. So I want to keep that. I'm going to do the same thing with this here. So I've got 3y is greater than negative x minus 4. Just put the x first. Divide by 3. I'm dividing by a positive 3. So my signs don't change. Alright, so there are my two equations there that I'm going to graph. So let's go ahead and get my graph out here. Okay, so notice that my red graph has a less than or equal to sign, so that's going to be a solid line, and we'll make that line in red. And this one has a greater than, but there's no equal to, so it's going to be a dotted line, and we'll do that in blue. Okay, so let's find some points here. Crosses at negative 4/3, which is about right there. And we go up negative 1 over 3. So we go up 1 over 1, 2, 3. Somewhere around here. And then we draw our line. And I'm just going to draw a line. And we'll stick it in there. Now this line is supposed to be dotted, but I don't know that I can make it dotted. Nope, can't make it dotted. Alright, we're just going to assume it's dotted because of this symbol right here. Okay, this one here is, we'll do this one in red, it crosses at negative 3, and the slope is positive 1/2. So, and we'll do that one. I don't know if I can change the color. Let's see if I can. I don't know if I can make it red. Oh, I can. Okay, so it's going to look like that. Alright, so again, we're going to assume that you remember that this one is a dotted line. I'm sorry that I can't make that dotted. And I've got 4 different places to plug in numbers. Okay, so I've got 4 regions. So what I'm going to do is I've got to try a number from each of these 4 regions. 1, 2, 3, 4. To see which ones actually are going to work out here. Now, since it's not a story problem and I don't need positive numbers or negative numbers or a combination, I have to try all of them. So again, I'm going to put a 0 in. So get my original problem here. There it is right there. And put 0 in. So what we do is we plug in a point here. So like 0, 0, we plug it in here. 0 minus 0 is greater than or equal to 12. That's a wrong thought. 0 plus 0 is greater than negative 4. That's also wrong. So this does not work. So let's blacken that out, saying we're not going to use that. Okay, let's look at a number down here. Let's try, you always want to try a number that's kind of in the middle here, not close to this line, because you get one close to the line and your graphs aren't exact and you may be on the other side of your line even though your line is here. So I usually try to pick a number like in here. So let's pick x is negative 4, y is negative 3. That looks pretty safe. So 2 times negative 4 is negative 8, plus 12 is 4. That's greater than or equal to 12? No, that's not. So we're going to blacken that because that doesn't work. I mean, if it doesn't work for one, it doesn't matter if it works for the other. All right, so let's pick a number down here. Let's pick negative 4, 1. I like using 1. So negative 4, or I'm sorry, 1, negative 4. Okay, our x and our y. So we put a 1 in here. So 2 plus 16 is greater than or equal to 12. Yes, that works. Okay. 1 minus 12. Negative 11. Is that greater than negative 4? No, it's smaller. So because of that second one doesn't work, we have that. All right, so now we've got the third one. And let's use 4, negative 2 in this one. So we do that, we get 8 plus 8 is 16. That works. 4 plus negative 6 is negative 2. Is negative 2 greater than negative 4? Yes. So the answer to this problem is any number that fits in there. And that's it. Okay, so example number 5. We have that same car rental problem. And we're going to look at our constraint inequalities here. Again, what's going to limit what our graph looks like. So they give us y is less than or equal to 71 minus x. Okay, what that means is we had a total of 71 cars we could purchase. Well, if we're buying a certain amount of compacts, which is x, now we don't have 71 anymore. We have however many we bought of the compacts subtracted from 71 to know how many of the intermediate we have. So that's where the 71 minus x comes from. We also have the dollar amount, y, is less than or equal to, we had 1,260,000, but we're just going to call it 1260 instead of 15,000. We'll call it 15. And that's divided by 28. Okay, so that's 28,000, and they have 28 instead of thousands. We also know that x has to be greater than or equal to 0, and y has to be greater than or equal to 0, because x and y are mean the quantity of cars that we're buying. Okay, so if you remember, we graphed these, and we had a graph that looked somewhat like this. And then we had a red graph of the other equation, so we've got, two different equations there. And they're both less than or equal to, so they're both solid lines. So we had another graph that looked somewhat like that. Okay, so that means, again, we have to look at 1, 2, 3, 4 different places here. Now, as we try each of these 4 places, we find out that this bottom one actually works. But the problem we run into when we use the bottom is we get into negative area here. So what we have to do is we have to determine the numbers that are going to count here. And we can't go into negative territory because x and y cannot be negative because they're quantities. So that's the whole idea behind the constraint. Okay, we're constrained. We're kept from using all of the options because of the story problem. All right, so let's jump to advertising example B, or example 6, I'm sorry. Okay, so very similar to the car dealership one. It says write the inequalities that describe the mayor candidate's advertising needs. All right, so this mayor is trying to reach a certain number of people. X meaning that we're talking about television, and Y meaning we're talking about radio time. Okay, so we can reach 0.09 million through watching TV. So we'll call that X. We can reach another 0.006 million by radio. And the plan is we want to reach an audience greater than or equal to 2.16 million. Okay? So that is our one inequality that we have here. We also know that this candidate can buy no more than 80 minutes of advertising time. So between TV and radio, add those together, we can have no more. That means it's got to be less than or equal to 80 minutes. Okay? We also know that X, since that is a number of minutes, has to be bigger than 0, and Y also has to be bigger than 0 or equal to 0. Okay, so that's basically my constraint here. Okay, so I go ahead and solve this, and the way I would suggest solving it is I would move this over here and just say y equals 80 minus x. Then I would take this 80 minus x and put it in here for y, and you don't have any exponents. It stays linear. It stays just x's and y's, and you do the math, and you end up with an x that equals 20 and a y then that equals 60. So you find x is 20 here, then you plug 20 in here, 80 minus the 20 that you found, and you get your y equals 60. Alright, so those are your two numbers for x and y. And all that x and y represents is where these two inequalities intersect on the graph. So if we go over 20 and up 60, we end up right there. That's where they intersect. That's what these numbers give me. Okay, that's it. But then I need to be able to draw the line of this one and the line of this one. So in order to draw the line of, say, this equation right here, I have one point on the line. I have to have another one. So what I suggest doing is find out where this line crosses the y-axis, or where it crosses the x-axis. Now in this case, I would probably choose to find out where it crosses the x-axis, since this point is further away. Gives me a little bit more accurate line than if I found a point here and just connected these two dots real close. If I had a bigger space between them, so I'm going to go ahead and do that. And when I do that, in order for it to cross the x-axis, y has to be 0. So I'm going to write this equation right here, 0.09 x plus 0.006 0. My y is going to be 0. So that goes away. So now I have, I'm going to divide both sides by 0.09. Do my handy dandy calculator and find out that my x value is 24. So that's where it's going to cross, is at about 24. So I'm going to draw a dot there at 24, and I am going to, let's see, draw a line that's blue and see if I can get it somewhat accurate. Okay, so there's my line. That's my line of this equation right here. Okay, next thing I'm going to do is I am going to draw a line of this equation right here. So I also know that it crosses at this point here, but I'm going to find out where it crosses the x-axis. So again, I'm going to use my y equals 0 here. So 0 is less than or equal to, or I guess basically what I'm doing is I'm just going to put an equal sign here. I'm not really interested in greater than or equal to or less than or equal to. I'm interested in equal. So therefore x equals 80. So that means it crosses the x-axis at 80. Okay, so let's move our graph over here and get my little symbol here. We'll do this one in red, and I'm going to go through this point and also go through about 80 there. Not very 80-ish, but okay. So there's my red line showing where, trying to get rid of some stuff here. Okay, so at this point, I've got, again, 1, 2, 3, 4 different places to look. And when I plug things in, I find out that the one that works, or the part that works, is going to be the shaded part right here. Okay? Can't go down into the negative section because you can't have a time being negative. So, therefore, that's my answer there. Alright, so one more video and we will be done.